Hello again, let's get started. Follow my cursor. The negative of the square root of 1 over 25, well, that you just keep the negative out here. And remember, the square root, as long as a and b are positive, the square root of a over b is the square root of a over the square root of b. So we have the square root of 1 over the square root of 25, but the square root of 1 is just 1 itself. Now the square root of 25 is 5. So there's that. Let's look at this one. The square root of 36 over 25. That's just the square root of 36 over the square root of 25. And you do the square root of 36 is 6 up here. Now down here, the square root of 25 is 5. So that's pretty basic. Let's go on down the page, or to the next page. Now the square root of like 72 over 25, that would be the square root of, well, notice that now 72 is not a perfect square. Let's go ahead and fragment. That's radical 72 over radical 25. But guys, 72, the biggest perfect square that will go into 72 is 36. So break 72 up into 2 times 36. And remember that 36 comes out as a 6 under the square root right here, because the square root of 36 is 6, so 6 comes out. The 2 stays in. So you get 6 radical 2 over 5, and you can stop there, or you can think of that as 6/5 radical 2 if you'd rather, but you can stop here if you wish. Now let's look at this one. The square root of 25 over 108. You just break it up. That's the square root of 25. Now that's the square root of. Now 108, this is 108, but we break it up into 36 times 3, because 36 is the biggest perfect square that works here for 108. That goes into 108. Now the 36 comes out as a 6, the 3 stays in. Now our answer, but it's not our final answer, we get 5 over 6 radical 3, but we don't want a square root in the denominator. So what I do is I do a little trick, and I kind of was concise. I skipped a step. Let me show you the step that I skipped. What you do is you stick, it would be good to have, you know what, my answer may not even be right. My answer is incorrect anyway. Sorry guys, this answer is wrong. My bad. So my final answer was incorrect. So let's work on this. Now what I'm going to do is I'm going to stick I want 2 radical 3's on the bottom, not just 1. So now it's okay to multiply the bottom by another radical 3, but you have to stick a radical 3 multiplicatively upstairs to counterbalance that, like this. So since this radical 3 came here, this one has to come up here. All right, and now you're like, what was the point of all that? Well, the denominator, notice by associativity we can multiply the radical 3's first before we ever do anything with the 6. But rad 3 is just 3. So we get that. But hey, you see, notice what happened. Our denominator doesn't have any radicals anymore. That's a standard practice in math to get the radicals out of the denominator. That's going to be a recurring theme in mathematics, to get the radicals out of the bottom. It's okay to have them up top, but for some reason it's just considered bad manners to have them on the bottom. It's not incorrect, it's just bad manners. But anyway, this is the good-mannered answer. 5 rad 3 over 18. Now another just as good-mannerly answer, I'm going to put, can't type anymore. I'm going to put or 5/18 radical 3. Whichever way you'd rather type it. When it's like this, the radical 3 is multiplicatively understood to be up here with the 5. But anyway, just whichever form. Let's go to this next problem. Let's say I have radical 50x cubed over radical 128x. Now 50 and 128, they're not, neither one's perfect squares. But notice we can bring them inside like this and put 50x cubed over 128x. X cubed divided by x is x squared up top. And the 50 and 28, they reduce. 2 goes into 50 25 times. 2 goes into 128 64 times. But hey, these are perfect squares. X squared is a perfect square. Now guys, remember, we're assuming always, unless I say so explicitly otherwise, that all variables are positive. So we're assuming all things are positive variable-wise. So whatever letter it may be. So the square root of 25 is 5. The square root of x squared is x, which is a positive number by assumption. And the square root of 64 is 8. And I technically skipped a step. I skipped the fragmentation step where rad a over b is rad a over rad b, but I don't think that's going to throw you for a loop. This is like here, radical a over b is rad a over rad b, but it's pretty trivial what we do here. Okay, so there's that. Now let's look at the next problem. The square root of 50x cubed over the square root of 128x to the fifth. Well, we bring it together like this, and then we reduce. Now, x cubed over x to the fifth is 1 over x squared, or in other words, to say the same thing, x squared just comes down here. It's not upstairs now, it's downstairs. Now, the 25 comes out as a 5. Notice that when we reduced 50 over 128 to 25 over 64, we got a perfect square. 25 comes out as 5, the 64 comes out as 8. So there's that. And notice, guys, let me insert that step. There is a good teaching moment here to be had. Let me do this. The moral of the story, sometimes together is better, sometimes fragmented apart is better. So, pardon the moment of silence there. But notice, when we first started, we started out with this guy here. We came together like this. And then we reduced and simplified like this. Then we fragmented back apart again to get this. And in a similar manner, it's bothering me. I was going to not do it, but I'll do it. We could have done the same thing up here a minute ago. Notice we fragment back at the very end. But that's after we've done some reducing and cleanup and all that. But anywho, there's that, and I hope that helps. And these problems, this one and this one, they're not the same problem, but they're sort of similar. Notice in this one, there is one key difference. Here, x is up top. Here, x is on the bottom. This is not the same as this. It's one thing to have x up top. It's another thing to have x on the bottom. And another thing I'd like to point out, you can think of as 5/8 x. This one, you can't do that. What you could do is, well, really, you're better off just leaving it like this. What's going on is this can be thought of as 5/8 times 1 over x. But, guys, I'll be honest. This is clumsy. So let me put, that's just, to me, that's correct, but it is correct, but it's clumsy. So just go with this, okay? This is, you can go with this, but I find this guy right here to be clumsy. So the moral of the story, this guy does not equal this guy down here. 5/8 times x in general is not the same as 5/8 times 1 over x. The only time they are the same is when x equals either positive or negative 1. But in general, x is going to be something else most of the time. So there's that. The only time you can equate two things is when they're always the same, okay? Okay, let's look at this example right here. The square root of 50x cubed over the square root of 128x to the negative 5. Well, we bring it together like this, all under the same square root. We're assuming x is positive as always. We bring the x to the negative 5 up, and it becomes x to the positive 5. By the law of exponents, you add this 3 and this 5, and you get 8. So you have the square root of all this. Then you can fragment like this. But the square root of 25 is 5. You remember, you take the 8 here, and you divide by the understood 2 out here, which is the index that you can't see. And you get 4 here. And then next after that, you do the square root of 64, and you get 8. So there's this example. Let's look at this one down here, where my cursor is now. Radical 50x cubed over radical 128x to the negative 1. So we bring it together. Now that x to the negative 1 is going to come up here, and there's just x itself, or x to the 1 power, which is x itself. And I'll write that step down. And so it's going to be 50x cubed and just understood x over 128. So there's that. But then the x cubed times x, you add the 3 in the understood 1 and you get 4, okay? And the 50 over 128 reduce again to 25 over 64, and that's 5x squared over 8. And again, x is always understood to be positive. Let's look at this one. Again, same idea, except instead of x to the 1 coming up, x to the 4th comes up. And so we get 50, the x cubed, but then the x to the positive 4th. And the only thing left down below is 128. And then reduce again, and you add the 3 and 4 to get the 7 here, and you just go through the same stuff. Now, watch out for something, though, guys. Be careful. There is another step I need to insert. And, well, besides the fragmentation step, this is more important, though, to me in a way. I can go ahead and you can go ahead and fragment now if you want to, but guys, x to the 7 is an odd number, and that doesn't jive well with a square root, which is order 2 radical. Let's break up. The biggest multiple of 2 that goes into 7 is 6. So let's break this up as x to the 7th up into x to the 6 times x to the 1, like that. Now we still got that 64 down there. Okay, now this time I think fragmentation, it would almost be confusing for me to not fragment, so let me fragment, and we would get radical this over radical that, or the radical top stays up top. Oop, and it's not, hold on, it's not cooperating, just a second. And then, so radical this over radical that. But now, guys, see what happens. Remember from previous, from times past, the 25 comes out as a 5. You just do the straight up square root of 25 to get 5. Now, I messed up. Did I make a boot? Yeah, I made a mistake. That's a 3 there. So, yeah, that was a big one too. So the x to the 6 comes out as x cubed. And then, now the x to the 1 has to stay inside the radical. And then, now the square root of 64 is 8. And that goes down below. Guys, that'll be all for that one. And notice that we're stuck with the radical x. There's several ways to write this, but this is good enough right here. Another way to write this, there's actually several. This would be an example. 5/8 x cubed radical x. You could put the radical x in front and say 5/8 radical x times x cubed. I think it's better manners to put the x cubed in front of the radical x, though. I think that's more tradition. Either one is technically correct. There's several different ways, but just whatever you enjoy. But that'll be all for this video. Thank you. I'll see you on the next video.